Good afternoon, everyone, and thank you for joining H.C. Wainwright's 24th Annual Investment Conference. My name is Mason. I'm a part of the investment banking team at H.C. Wainwright. It's my pleasure to introduce Ian from FuelPositive. Thank you.
Great. Thanks so much, Mason. Hi, everybody. Thanks so much for joining me today. I'm Ian Clifford. I'm the CEO and board chair of FuelPositive. I've put together a brief presentation for you to bring you up to date with our current status and ongoing plans. And hopefully we'll have a few minutes to respond to a few questions. I hope you'll find this informative. I always start with a land acknowledgement because of where we're speaking to you from in Manhattan. I want to acknowledge that we're gathering on the traditional land of the Lenape peoples, past and present, and we honor with gratitude the land itself and the people who have stewarded it throughout their generations. This calls on us to commit to continuing to learn how to be better stewards of the lands we inhabit as well, and that reflects heavily in the company that you're going to learn about today. As a result, we want to acknowledge that we are on the traditional territories of multiple Indigenous peoples in all the places that FuelPositive conducts its business. And our commitment as a company extends to all those places as well. This is, of course, our disclaimer. We don't have time, of course, to read through it now, but it's an important document. So please make yourself aware of it when you've got the time. I'm gearing this investor update today to people who already have a reasonable knowledge and sense of our company and are looking for up-to-date information. I've got a few slides to cover basic information about our technology. Then I'll review latest updates that we shared in our recent webinar last month on August 9th, and I invite you to our website to view that. It's quite an extensive update. There were several hundred people viewing that, very, very popular. And informative. And I'm really pleased to say that as of today, we aren't experiencing any supply chain delays beyond those discussed in early August. We, like many companies, have been facing a lot of challenges getting our technology out the door, but we're in great shape right now. We're continuing to validate our initial systems, and we're using a staged approach to validation. And we opened up for pre-sales on August 10th. So I'll provide a brief update on that as well. Launching our pre-sales was an incredibly important milestone for us because it's starting to solidify demand, which will dictate how and when we scale up our manufacturing. We also have a number of other new developments to share with you, so I'll get right into it. By a little way of background, FuelPositive is a Canadian-based company. We're dedicated to acquiring and introducing clean, sustainable, and economically viable environmental solutions that can be deployed now, not decades from now. Invented and entirely developed in Canada, our core technology is a containerized green hydrogen and ammonia production system. It's been designed to produce green ammonia on site where it'll be used. Our first customers will be farmers, and agriculture is our first market. To understand us as a company, you should know that we take a very strong position on improving the environment. We're looking to support farmers in all aspects of their operations to meet increasing environmental concerns. For example, we're taking a leadership role to help with water and soil preservation, mental health, and business sustainability, because most farmers, of course, see themselves as business people. And you'll see us promoting plant-based agricultural practices as a fundamental way to build global food security and feed the ever-growing global population. Most people don't realize that ammonia is one of the most produced chemicals on the planet, with 200 million tons consumed annually. 80% of ammonia manufactured globally today is used in agriculture by farmers as nitrogen fertilizer. The world depends on ammonia fertilizer for food security, and that's why we're focusing first on ammonia as a fertilizer and on farmers as our first customers. Ammonia is also commonly used in many other sectors, as you can see on this slide here. As well, the concept of green ammonia is opening up additional sectors beyond the traditional ones, particularly where green ammonia can be used as a substitute for fossil fuels and as a carrier of hydrogen. From where we sit, there's a massive role for green ammonia in all our futures. However, there's two really big problems with ammonia today. The first is that while we rely on it as fertilizer for food security, the traditional method of producing it in massive centralized refineries is one of the most emissions-intensive manufacturing processes in the world today. So production of the very product that we need for food security is contributing to climate change, which is a major threat to farming and food security. It's quite a paradox. It's clear to us, just like we know we need to reduce our reliance on fossil fuels because of the damage fossil fuels cause to our environment, we also need to find a way to make fertilizer without polluting, to continue to feed a dramatically growing global population. And moving ammonia from refineries to end users, the production of that ammonia has a huge carbon footprint reduction. Finally, the supply of ammonia can also be wildly unreliable in terms of delivery to the farmer and in escalating costs. For farmers, it's a nightmare that threatens to put many out of business. This is Tracy and Curtis Hebert. I think telling a bit of their story is the best way to understand the impact of today's ammonia supply chain problems. The Hebert family run an 11,000-acre multi-generational crop farm in Manitoba, Canada. On the right side of the slide is an aerial picture of the heart of their farm that includes their offices, equipment, maintenance facility, significant fully automated grain handling silos, which includes grain drying. And you can even make out their 200 kilowatt solar array in the photo as well. Theirs is a third generation farm, and they want to take care of their land so their kids can eventually take over the farm. The Heberts routinely use anhydrous ammonia to fertilize their crops and have been doing so since the 1960s, when anhydrous ammonia was introduced to Manitoba. They need roughly 600 metric tons of it per year. Recent increased fossil fuel prices and supply challenges have pushed anhydrous ammonia prices to over $2,000 per metric ton, and that's a 300% increase over 2020. And so that's well over $1 million of input costs for a farm the size of the Heberts, and it's simply unaffordable for a lot of farmers. The skyrocketing cost is only part of the problem. The supply chain is so unreliable that the Heberts often don't know when their fertilizer is going to be delivered or how much they will receive. That's a major problem for farmers because there's a right time and a wrong time to apply fertilizer. And it's critical to apply the right amount at the right time. A late delivery can mean a smaller crop. Insufficient fertilizer will also reduce the yield. When farmers have smaller harvests, food security is threatened. All of this means a great deal of stress to farmers like Tracy and Curtis. And that's why they reached out to us a number of months ago when they heard we were developing a system to produce green ammonia on farm. They recognized our systems would give them the stability of supply and price they wanted. Since then, we formed a formal partnership with them, and they'll have our initial demonstration system tested on their farm. And we're busy together now preparing for that to happen. Our system is basically a mini ammonia factory in a box. It fits within standard 20-foot shipping containers that will be placed on the sites where the green ammonia will be used. Our technology uses only air, water, and sustainable electricity, such as solar, wind, or hydroelectricity, to produce green anhydrous ammonia. It consists of three main sections, as you can see in this image: a hydrogen extractor to separate hydrogen from water, a nitrogen extractor to separate nitrogen from the air, and a converter that combines the hydrogen and nitrogen to make ammonia. The converter is currently the core technology that we've invented, and we filed for our non-provisional patent in June of this year. And farmers from all over the world are contacting us, telling us our system will make a major difference in their lives. An on-farm fuel-positive system will produce their fertilizer cleanly with no carbon emissions, and it's built around a decentralized model, which means it'll produce green ammonia on their land in the amount they need at a cost that's stable. Farmers will no longer need to rely on an unreliable supply chain. For the first time, farmers will be in control. Ultimately, the green ammonia from our system will also be used as fossil fuel replacements to run grain drying equipment and internal combustion engines on farms. Soon, farmers would no longer need to buy fossil fuels to run their farm equipment, but could produce what they need to power all their farm equipment and systems right on the farm, thereby eliminating the highly polluting and expensive fossil fuel supply chain as well. So a pretty radical model in that sense. The first demonstration system we're building right now will produce 300 kilos of green anhydrous ammonia per day, or 100 metric tons per year. It'll be housed in 3 modified 20-foot shipping containers. And as we make refinements to the system, we expect the system to be smaller and more efficient. And the systems are designed to be scaled up and down as necessary. For a farm the size of the Heberts, 6 times the initial capacity will eventually be placed on their farm to produce the amount of ammonia that they need. System uses about 476 kilograms of water per day to produce 300 kilograms of green anhydrous ammonia. So for a farmer to run a 100-ton system off grid, they'd require about a megawatt solar array with appropriate storage, and that array would take the space of about a football field. So not a huge land consideration for a farmer. Operating costs in Manitoba, as we announced in November of last year, remains at around $560 a ton. Based on local electricity cost. And interestingly, that compares to about $2,000 per ton now retail delivered to the farm. So it's a huge savings for farmers. And if they go fully renewable on farm, they have, say, a average cost per kilowatt hour of, say, 2 cents, they can lock in $200 to $300 per ton anhydrous ammonia cost for decades. So this is taking a commodity priced material and actually giving it cost security and supply security and predictability for decades. So it's a pretty radical model in that sense. This shows what the system looks like on a farm. Water and air go into the system. There's renewables in this context. The Heberts in Manitoba live on a very clean green grid. It's also a very low cost grid in North America. And we're helping farmers also design renewable systems to put on farm to create the cost efficiencies and longevity efficiencies of the system as well. Our system is good for about 3 decades, and it requires a major overhaul at about the 15-year mark, but a very stable, very dependable system, and very straightforward from that sense. Our first demonstration system, I'm sorry, I forgot to go forward here. That's the application on farm. Our demonstration objectives, our first system, we're using a third-party manufactured hydrogen and nitrogen extractor. And that interfaces with our custom patent-pending converter system. And it'll be fully validated on our premises before it goes to the Hebert's farm. Once on farm, the system will be heavily monitored, which will give us results under dramatically different weather and operational conditions. Those ongoing results will, of course, shape the next 2 demonstration systems from a design perspective. The second demonstration system will have a smaller footprint. Our objective is to improve the hydrogen extractor in terms of cost, size, and integration, because it represents about 80% of the capital cost of the first system. And we intend to get that cost down rapidly. The third demonstration system will have additional refinements to further reduce the size and cost of our on-site technology. At the end of the demonstration project, all 3 demonstration systems will have been tested on farms under a full range of operating conditions. Then we'll be ready to begin larger scale production as a result of all of that work. We put out a news release early in August to say we had been hit by some supply chain challenges and facility availability issues. And that's consistent, of course, with many industries to varying degrees. As a result, it became standard practice to design with the ability to pivot when faced with challenging circumstances. And because of that, we're working around any delays, and that is allowing us to stay pretty close to the schedule we shared at our AGM in April. Validating testing has begun on key portions of the system, and the final system validation is now looking to be completed in November, and we'll get our system onto the farm right after that. We can't say exactly when, because of course things could change between today and then, but it's important to know that these delays are all supply chain related, technology rollout, all of our testing, everything is progressing as planned, and there's no technological setbacks. We're starting to validate key systems now. We're using a staggered approach to that. It's a bit more work, but the results will be the same, and we're saving precious time as a result of that approach. Most importantly, we're building a true and practical farm-ready system from the get-go. This is not a laboratory system by any stretch. Our system is being built right now, fully climatized and ready for the true industrial conditions it'll expect to see in the real world. That is all progressing as planned. So here, there's a lot of, I mean, there's a lot of companies that we're talking to trying to downplay global supply chain delays, but they're real, and they do have an impact, of course. We've got an incredibly experienced team to help work through those challenges. Given the realities of the last few years, we expected delays and put plans in place to mitigate them, which is now reflected in our current progress. When we look through the modules that we're going through the certification now, the first one is our hydrogen electrolysis module, and that was built for us in Europe. According to very strict specifications, and that was expected to be delivered to Canada in March. So as we saw shipping delays, both Atlantic and Pacific, but these systems obviously coming over the Atlantic, we decided to validate that system in Europe to save that validation time once the system was here, not knowing how long it would be sitting on a dock before it actually arrived in Canada. What that means today is that major component of our technology, of our initial systems, has already been validated. So we've got a 60% validation of the entire system before that component even arrived to us. So that's helped keep us on track from a timing perspective. Then there's the nitrogen module, similarly built in Europe for us to spec. We did this time expect the shipping delays, did exactly the same thing in terms of validation, and again, received the same level of advancement of our timeline as a result of doing that testing here. So that, of course, is the heart of the compression side of our system, and that means today we validated over 60% of the entire system. So we're actually ahead of our stated schedule from April. Sorry, where are we? And then the last piece, which is significant, is the converter technology, and that represents the remaining 40% of the FuelPositive process. It's fully designed by us and protected by our non-provisional patent application, as I mentioned. That system is nearing completion right now and is being validated over the coming weeks. So we've been really careful in choosing our suppliers, making sure that we're sourcing materials and suppliers who have readily available materials right within our production area. We're trying to do as little as we can in terms of broad geographic reliance, just because it's too risky. And being in Canada, we have access to so many great not only manufacturing partners, but also raw material suppliers as well. So we're very, very well situated in that context. Okay. Now I'll just quickly talk about scaling up. We've been working very hard, as I mentioned, to find the right supplier and vendors to help us through the process. And we've got a tremendous team led by our Chief Operating Officer, Nelson Leet, who comes from a automated manufacturing background to help bring all of that activity forward. We've done extensive hiring since our AGM. We've filled a number of very important key positions. We're a little over 20 people now. We expect we'll probably double in size over the next 6 months as we start doing batch manufacturing of our technology. We've moved into a new facility just under 10,000 feet that'll allow us to do batch manufacturing, and initial orders and interest are coming in that context and allow us to meet demand there. We've been very active on-site preparation for the installation later this fall, and we're helping the Hebert family and their staff prepare a perfect site for our system going in shortly. Here's just a very quick image of the type of setbacks and the type of space that would be required for one of our systems. So it would have a dedicated roadway and safety and fencing and so on to allow us a safe environment for our technology. We started pre-sales about a month ago. We've got tremendous interest. We're not yet publishing numbers in terms of that interest as we're going through the sales process, which is quite involved. Each farm has a very different operating environment and need and application. But we're finding that a highly consolidative model on our sales process is very, very effective at this point. And we couldn't have a better global environment for this type of technology and these types of end users. Farmers are desperate for solutions that are viable and effective. Making early adoption easy. So we're doing a lot of work federally in Canada, provincially in Canada. Our initial systems will be going into Canadian farms, but we'll be expanding to global markets over the coming months. Excuse me, we're getting tremendous interest from all over the world, as you can imagine, but we're helping put together as much support structure for farmers to implement our technology on farm. So, and we talk about that on the website as well, and you can get into some of the details of those activities. One emerging market that we're working on with a lot of interest, it's in controlled environment agriculture. So this is greenhouse vertical farming. We've got a great solution because we're producing continually. So the demand for fertilizer is continuous, of course, in a controlled environment situation. So we fit perfectly into that model. We just started working with University of Guelph in Canada, one of the top agricultural universities in the world, and they're helping us design programs and output programs for our system to integrate perfectly into controlled environment agriculture. So that's, again, very exciting. So I'll just take 2 seconds to summarize, and hopefully we'll have time for a couple of questions. We've come a long way in a very short time. FuelPositive, the beginning of last year, actually, we became FuelPositive, and we've worked incredibly hard to build an amazing team over the last year. We've got tremendous advisors that we've brought on as well, and all of those you can see on our website, and I invite you there to take a much closer look. Validation of our initial systems underway with an expectation of full validation in November. The Heberts, as I said, are getting ready to receive, and pre-sales are underway, which is absolutely important as we plan the ramp up of our production. In terms of share metrics, we've seen a lot of stability in the stock over the last 12 months. And there's been great response to the material milestones along the way. And we expect we'll have a lot of commercial milestones coming over the next 12 months, as I've outlined, and a tremendous amount of interest in the commercial rollout, obviously. I mean, as we transition from pre-commercial to commercial. So that's that. This photograph is just inside of one of the Hebert's tractors. They have the most incredible automation and technology on their farm that I've ever seen. Their equipment is accurate within about 2 or 3 inches accuracy. These are tractors and combines with 120-foot wide application systems, and they run them so accurately down the fields, and they're able to maximize their efficiency on farm. So they're really excited to have a system like ours that is going to allow them to be extremely precise in terms of their fertilizer needs. So thank you. Questions? There's one there.
Two. What is your cash runway call for, given your current projections? You know, how much you have there?
Right. Yeah, no, we're burning about around $200,000 a month now. We're sitting a little under $4 million today. But we're now starting to spend a lot more money, obviously, on the capital side of the equipment. So we've got a number of initiatives, some federal and some provincial, as it relates to support for technology development in agriculture, specifically in Canada. So we expect that we'll get some support there. And then we'll see. It really depends on how quickly we need to ramp up and how we'll capitalize that ramp up.
One follow-up. In your Hebert example, I think you said they need 6 systems or so.
Yeah.
What is the capital outlay that they're going to be looking at?
It's yeah, no, so that's a great question. So the core system is about 950,000 Canadian dollars, so just under $1 million. The site preparation will probably be in around the 300,000. It'll vary farm to farm, but about 300. So they're under 1.5 in terms of getting the system on and operational. Adding more systems, we don't have to just, we don't replicate an entire system, so we can add to it. We share control systems and those sorts of things. So it's a lower cost addition to add to it. But return on investment today, especially in the price of gray ammonia today, is a very short horizon. If those prices continue to stay high, they'll obviously get a great return on investment very quickly.
FuelPositive, who's your competitor?
In the small, very few that we're seeing in the on-farm or end user environment today. There's some universities who are doing some work, sort of small scale modular, but nowhere near commercialization that we've seen. There are other competitors who are looking at larger output systems that would be more in the at the distribution level within nitrogen fertilizers. But we're not interested in that market at all. We think there's going to be channel conflict with major manufacturers and so on with that distribution, and we're very much focused on end users. And the great thing about farmers, they're not land starved, so putting renewables on farm, generating and getting that consistent supply and cost for decades is, you can imagine how it resonates. It's really exciting. Pardon me? Huge in Canada, huge in the, well, I mean, yeah, ammonia, yeah. So in terms of having green grid, you're looking at BC, Manitoba, Quebec. But if you're putting renewables on farm, it can be anywhere. I mean, and this is where, and from a global perspective, any site will work for a farmer. It's just, you know, sizing. Solar tends to be the most effective, but sizing your renewable generation appropriately will give you all of that stability.
All right, on behalf of the H.C. Wainwright team, we'd like to thank everyone for their time. If there are any additional questions, please feel free to stick around and chat outside the hallway.
Great.
But I do want to appreciate everyone for the time, and thank you, Ian, for that presentation.
Yeah, thank you.